When we imagine ancient civilizations, the idea that these people did not have much knowledge about science and much less about advanced technology comes to mind at first. Current knowledge is much more developed when compared to the past, but to say that ancient people did not have any advanced ideas is a mistake. Some civilizations had a vast knowledge of astronomy, considered ahead of their time. But what is the experience developed in antiquity? How do they impact us today? How do we know this? This and much more you will discover now. Welcome to Nebula. Archaeoastronomy is the science that studies the sky observation habits and methods of different ancient civilizations to find out more about their culture. How did the sky influence their customs? What was the importance of these people in the development of astronomy? How does this impact us today? This area of science uses modern astronomy, making parallels with the technologies used to observe the sky of certain civilization, and archaeology to study ancient records of observations and old equipment. The religions of some peoples were directly related to observation of the sky and the surroundings. That's the object of study for an archaeoastronomer, to find out what that connection was like. Therefore, it can be said that archaeoastronomy also fits as a branch of anthropology. How is it possible to know what these civilizations believed? One of the works of an archaeoastronomer also includes this. He must infer this type of information, analyzing broader characters of cultural, social, and intellectual aspects remaining from these peoples. Just talking about theoretical definitions of this branch of study would leave an explanation vague and without reason. Therefore, we have gathered some discoveries from archaeoastronomy to show how interesting this area of science can be. The Egyptians made incredible contributions to astronomy, which spread across Europe when the Romans conquered Egypt, incorporating this knowledge into the European scientific community. To begin with, we can mention that the Egyptian civilization was the forerunner in making time markings. This marking consisted of a 365-day calendar with 4-week months based on the phases of the moon and 3 seasons. The astronomy of the Egyptian people was closely connected with religion. A good example of this is the pyramids, which are oriented with frightening precision to the cardinal points. The pyramids were the great tombs of the pharaohs, which shows the connection of these people with astronomy. We know this kind of information because the Egyptians left many scriptures about their culture and customs. Some point to the relationship between astronomy and religion, with an estimated age of over 7,000 years. In addition, they were the first to make writing notes about their observations, a fact that helped preserve their knowledge so that it could be improved in the future. This civilization also developed its constellation system that had no Greek or Babylonian basis. These constellations were used to predict the next flood of the Nile River, which was the most precious natural resource of the Egyptians, for making agriculture possible in the desert and to locating travel in it, locating the cardinal points by the stars. Now let's talk about the most famous object of study in archaeoastronomy today, Stonehenge. Located in Salisbury, England, this circular stone construction intrigues scientists. In addition to the fact that we don't know its exact meaning, although there is a certain consensus among the scientific community that Stonehenge would be a cemetery, its construction is also mysterious. Most of the stones used came from places very close to the site of the monument. However, some scientists discovered that some of the stones were brought directly from Wales, over 200 miles away. It's not known why this very difficult to transport process was done or how it was done, but it's speculated that the stones were transported by the sea from Wales to Stonehenge. Archaeoastronomy is closely related to this monument, as it was discovered in 1960 that one of the many possible uses of this large circle of stones was to predict and measure important days of the year, such as solstices and equinoxes. Thus, its existence became of paramount importance for people who developed a sedentary lifestyle, since through the observation of this phenomena, it's possible to determine the changes in the seasons. To perform this type of sky observation at Stonehenge, one had to stand in a specific position within the stone circle. By observing the circular shape of the monument, we know that the people who built it already knew the concept of pi. It's important to remember why these achievements are so impressive. Stonehenge's inner circle was erected approximately 2500 before the Common Era, or before Christ, and its outer circle some 200 to 300 years later. In total, it is estimated that Stonehenge took 1500 years to complete. A study done using 5 stone tablets with scriptures from the peoples of Babylon found that at this time they were able to use integral equations, something thought to have been invented by Europeans in the 14th century. The Babylonians were students of the sky, but they had a much more direct mystical relationship with it. Therefore, it can be said that these studies were very close to astrology. The stone tablets used in this study were employed by the Babylonians for astrological study purpose. In this case, to calculate the speed of the planet Jupiter at different times of its orbit observed on Earth. Integral calculus is the determination of the area of an irregularly shaped graph. Using a system that reached the same conclusions as such a graph, looking at the speed of Jupiter, the Babylonians were able to accomplish this mathematical feat long before the Europeans. When they did this calculation, it wasn't through a graph like the ones we know today, but the mathematical principle behind this logic is the same one that was discovered in the 14th century. You may be familiar with the idea that the first computer was built just a few years ago, at a time when photographs already existed, but this is a misconception. The first machine to function as an analog computer was created much longer than the ENIAC, and had a complex system of gears. This analog computer is called Antikythera. It was discovered in 1901 in a very old shipwreck, inside a box with Greek inscriptions that point out the purpose of the object, to study the sky. 30 pieces were salvaged from the Antikythera, but almost all of them are rusted, cracked, or missing pieces. However, this did not prevent deep studies from being carried out with the uncovered analog computer. It was found from the fragments that the computer described the solar system, using an extremely complex mechanism of gears, almost like a jigsaw puzzle. The Antikythera was able to describe the movements of Sun, Moon, and the 5 planets known by the ancient Greeks, about important time markers for them, such as the Olympics. Another use of the computer was to predict possible dates for eclipses to occur. It is important to note that this did not always actually happen or occur exactly on the day for which they were predicted. Its main use, in addition to predicting astronomical events, was to be used as a calendar. There were many inscriptions with different ways of marking time in Antikythera, and one of them was the Egyptian calendar. This calendar had a year with exactly 365 days, which is wrong. It takes 365 days and 6 hours for the Earth to circle the Sun completely, so we use a leap year. Every 4 years, those remaining 6 hours from previous years make a full day, so a leap year has 366 days. The Greeks also had this knowledge, so to correct this curve in counting time and the observations not being affected, every 4 years the Antikythera hand was manually moved 1 day more. Thus, they made a kind of leap year, but without changing the calendars used in everyday life. It is always important to remember that the Antikythera was very advanced for its time, but is not exactly a perfect and sophisticated object as many newspapers describe it. It had some limitations due to the time it was built. However, it was rather surprising for its time, so much so that the next object of such complexity to be invented was the pointer clock, almost a millennium after its invention. Since only a third of the entire computer was found in the wreck, for studies about it to be possible, the researchers need to reconstruct the entire Antikythera from these fragments. For this, in addition to the recovery excerpts, some molds left on nearby stones and calculations based on the logic involved in the operation of the computer were used. As much as all of this research has been done, we may never know what the Antikythera looked like, as it appears to be the only example built by the Greeks. It is not known exactly what calculations were used for its construction, nor what it was doing on the ship that sank near the island Antikythera, from which its name comes. If you are enjoying the video so far, we ask you to subscribe to the channel to receive more of our content and explore the universe of science. With that said, we move on to the video. Now that you know more about some of the incredible inventions of ancient peoples, does the image of backward civilization still come to mind when we talk about the subject? Certainly, the fact that this knowledge was not so widespread contributed a lot to the thought that the only civilizations to do amazing things came after the Middle Ages, which is not true. The technological development of a civilization is not something absolute that can be measured. Each people has evolved in their way relative to the material conditions present throughout history. With this reflection, we say goodbye and wait for you in the next video. Thank you for your attention, and may the knowledge guide you.